Today's topic, I know it's a mouthful from this initial slide. We're really talking about address point data. We're going to look at a few things. So let's talk about our outline. We're going to talk about where your address point data probably comes from. Each of you may have different sources, or your address points were derived from different methodologies. We'll talk about those. We'll also talk about NENA's address point guidance and the format that NG9-1-1 requires. We'll talk about some common data oversights with kind of out-of-the-box address point data, which is fairly common. So we'll kind of see the areas that we see most, talk about the areas most often that need to be addressed. And then lastly, we'll talk about strategies to improve your address data accuracy. So where did your address data come from? There's a few options. Here are 6 general methodologies that are used for placing address points. Parcel method is calculated using your assessor county level parcel data. We also have property access, which would be like a driveway entrance. You can place a point there. Structure addresses or structure points would be placed on top of buildings. Site address points would be more equidistant placements if there are more than one building with the same address. Entrance address points would be at the doorway. And then finally, geocoding. In this instance, geocoding refers to placing an address point based on where it lies on an address or a road centerline range. So parcel and geocoding methods are automated. So that's fast, inexpensive, quick. And they're commonly used for rural or larger territories because they can be automated. The rest of those methodologies that I kind of went over require often manual point placement. So it requires a secondary level of oversight to look at where the address point is and where it should be for it to be as accurate as possible. We're going to talk, so let's talk about the parcel and geocoding methodologies a little bit more. As I said before, they are both automated, so you can run these through an ArcGIS program or some other GIS software to get some data points on a map. However, the parcel automation has some downfalls. One, it's a centroid placement, so it's going to look at the parcel shape and find the center of that shape and put the point there. That doesn't mean that it's necessarily on where the entrance is or the site or the building. So it's just a general in the middle placement. Also, parcel addresses are limited to 1 address per parcel. So you usually will have like a site field or site address for parcel information, and that's usually what is used to populate those address points. Geocoding based on road data, again, that's automated, but that it's based on a range placement. So with NG9-1-1, the road center lines need to have a left and a right from to range. So the address that you might have will be calculated somewhere along that from to range. So if you have a from 1 to 100 and your address point is 50, it'll be right in the middle. However, say that 50 address is actually slightly further east or west of that middle point, you can see where that reality might not match the geocoding. Also, there's a simplified parity, meaning odds and evens on either side of the road. If you have an odd address that should be on the right side, but it's on the left, those weird and unique addressing situations could be incorrectly labeled with the geocoding methodology. Pardon me. So let's talk about the NENA standards. This is the NG9-1-1 data schema that we at Cloudpoint work to bring our client data into. We have a lot of options. We have compared to old E911 field types, these NG911 is parsed further. So we have different fields for different aspects of an address's name. Most of the time we've been talking about all of these address number and prefix suffixes, the street name. But for this talk, we're going to focus more on this portion over here, this right side. So let's talk about what NENA requires. It needs an address point layer. They require it, but there's no requirement for completeness of this data. So it's up to the PSAP or the board to decide what level of completeness of data is acceptable. Obviously, what you have is what you have, but we should be working for a more accurate and complete data source so that we can make emergency response as seamless as possible. So NENA also acknowledges that it takes a lot of time and resources to fully develop complete and accurate address point data. So that without explicitly saying it, it seems that that's why there's no complete, like a requirement for completeness, because the time and the resources are to develop such a data set are extreme. So oftentimes when we're what the site address point data does is it helps provide a secondary layer to help locate sites that may not correctly geocode based on the road centerline data, or that use unusual addressing. So if there's a different or a more precise way of locating a spot, using site structure address points can be useful in that regard. It's worth noting that geocoding based on center lines is often done automatically with CAD data currently, and will often be done without speaking with absolute certainty in the NG9-1-1 environment. Geocoding based on the road center line can be done simultaneously as with looking at the address point data. So this address point data should be used to supplement kind of a secondary geocode or precise location address to help make those the road center line geocoding a bit more precise as a backup. Okay, so we're going to talk about sub-address fields because these are aspects of the address point layers that we haven't really talked about in great detail, but they're very useful in particular areas. Obviously, what like the previous slide referred to, all this work is time intensive and resource intensive. So understanding what these fields are, when they can be used effectively, can help save your department or your organization a lot of time and resources by kind of understanding where these fields are most useful. So these are elements of addresses that identify a specific location within a greater site or structure. So they can also be used to like refer to commonly used names as well. We have 6 fields: building, floor, unit, room, seat, additional location information. So quite a few fields to utilize. And you can see that these kind of are in increasing level of specificity. So building, floor, unit, room, seat. It's kind of zooming in on a particular location. And we have, we'll talk a little bit about what NENA expects those fields to be filled with in just a bit. So this kind of jump back to our methodology of address points. Oftentimes what we see with clients coming to us is that they have address point data, and it's very useful. Any data is useful. But it's usually utilizing a single methodology. So they've used their assessors parcel data to populate a centroid-based address point field. That's good, but again, it only utilizes a single address per parcel. So for any duplexes or apartment buildings, right, those would be errors or missing information. Geocoding from roads, as we talked about a little bit before, rarely aligns with reality, whether that parity is of an address is on the wrong side, or if the range is wider than where the actual placement of the addresses are. So either one of those methodologies should, for more accurate data, should be reviewed by a GIS professional to either move those data points to a site or structure or an entrance. That would greatly increase your data accuracy. But what I want to focus on here to kind of bring back in the subaddresses are multi-point place types. Because in either of these automated placement methodologies, multi-point place types are not well represented. So what are multi-point place types? There are a lot of them. And in general, they are places that really deserve multiple address points, or using those sub addresses to help responders know where they're going more accurately. So apartment buildings, schools, obviously schools are a hot topic and would be very useful. University colleges in that same vein. We have a long list here. I won't read them all, but you can see that how having accurate addressing data for these areas can help first responders respond efficiently and kind of move with the knowledge and certainty that they are going to the right place. Okay, so I took a few screenshots from the NENA document itself to kind of show some methodologies and what sub addresses are. So similar to methodologies of placement for address points, we still have some methodology choices to make with sub addresses. So on the left, we have a unit or an address of 3421 Sheridan Drive, and we have a blown up picture of its unit layout. So the sub address for this particular parcel or particular address could be placed within each unit, kind of a centroid based model. So we have unit B here in the upper left to showcase exactly where that unit is within the building. Another option, equally valid, it's up to the responding agency or the client that we're making this data for or in consultation with, where you can put the sub addresses at the entrance of where that unit is accessible. This is obviously a bit more unified, so we have stacked units in a singular doorway. You could also move these points to the doorway of each unit for another doorway option or access option. Over on the right hand side, we have a mobile home park with lots displayed. Oftentimes mobile home parks will have a single address with a lot or a unit or a number associated. So having these lot numbers recorded in your GIS data in the subaddress fields accurately and consistently is very valuable for emergency response to respond to the right location. Lastly, in this bottom right, we have a slightly different use. So we're using a different subaddress field. Again, this is for 3390 First Avenue Southwest. And we have multiple areas. So we have the tennis court, which is labeled with a point and the word tennis. And ball field 1, ball field 2, building A. All of these are valid subaddress names that can be put into that additional address information field if it doesn't comport with any of the other fields available. Okay, so let's talk about what NENA kind of recommends when we're talking about subaddresses. So first off, there needs to be a balance struck between the level of detail needed for a subaddress. Do you need 1 point for an entire building or 1 point for each unit within that building? So that requires right away kind of a prioritized mindset. We need to start identifying areas or units or place types that need more attention, rather than, you know, populating any building that has multiple rooms. We don't necessarily need to spend the time populating all the subaddress fields. Often it's worth noting that oftentimes the subaddress information isn't needed to route the call to get responders to that scene, but it's useful once they're there to then know exactly where to go for where that call is needed, where the assistance is needed. In general, the level of detail begins with relatively low levels of subaddress information, so units or possibly room, but more those like maybe baseball fields, right? We're kind of looking at large areas, and then with increasing granularity as time permits, going into, you know, it even has seat information. So in a classroom, you might have multiple seat options that you could put in. Finally, the decision on where to utilize this is kind of up to the agency. Like I said before, there's no requirement on this completeness. It's just kind of identifying where your emergency responders need more information about a certain area. Let's see. So thus far we've been talking about subaddress points and the NG9-1-1 model. I do want to say that there is room within the NENA standard to have related table structures, which may be useful if you already have some of this data in a related table built out. You can bring that over. That's a fairly particular and unique case, but if you have some related table information that you're not really sure how to use, that you're curious about, feel free to reach out to us. We'll talk through that with you. And then placing multiple address points with subaddress information on multi-story structures. So we're talking about, you know, office buildings or hotels with, you know, 3 to 10 stories or higher, could use three-dimensional environments to assist in placing those individual points, and therefore assist in emergency responders knowing exactly where the response is needed. So three-dimensional environments are coming, and thinking about 3D models as we're doing subaddressing, keeping an eye towards the future is valuable. It's going to be able to make sure that your data can translate into that as seamlessly as possible. So let's talk about some strategies to improve your data accuracy. So the address point placement should be based off of an authoritative list of addresses from your addressing authority and accurate GIS data, both imagery, parcel data, whatever we can pull. That information from addressing authorities needs to be verified against other record sets. So pulling in more data is always better, so that we can kind of sift through it to pull out, those unit information details, or apartment building numbers or duplex numbers. It's also strongly recommended that you have some sort of feedback mechanism built into, or start discussing this, a process where you can get feedback from your emergency response staff and the addressing authorities on problem areas or areas that they identify as being in need of more accurate addressing. And then finally, a good strategy would be to take all the best data that you have available for a given area or situation, and using multiple address point methodologies for larger areas to be able to combine the strengths of all of those methodologies and leave you with a more accurate data set in the end. So what other records are available? So kind of looking at those other record sets that NENA brings up. This is by far not an exhaustive list, but you can use the U.S. Postal Service National Address Database, get in touch with them, possibly customer databases from your local water or electricity utility provider, voter registration lists, possibly. Obviously, political lists need to be approached with caution. Then building or campus evacuation plans or employee maps, or like grounds crews. All of those are valid and useful data sets that you can then bring in and update the address point data. So this is essentially a breakdown of how Cloudpoint approaches these projects, specifically precision addressing services. So first off, we define a scope, because like NENA said before, time and resources for this work are intense. So by defining a scope, we protect ourselves and the client from this kind of spinning out of control. So really identifying a prioritized list of multi-point address types or place types is important. Then we conduct our research on those areas, and if necessary, visit them. But we will conduct as much research as we can to collect those other data sources. And then we go upon populating that data compliant with the NENA and more importantly, your state-specific NG9-1-1 schema requirements. Lastly, just to kind of highlight the three-dimensional model that NENA talks about, this is kind of the cutting edge of NG9-1-1. We're seeing more emphasis and kind of the shifting of focus towards a three-dimensional like aspect to NG9-1-1. So I encourage you to look into this area. We have a separate team from public safety, but we work really closely together on this work specifically. Our indoors team already maps buildings and develops three-dimensional models. So there is the possibility of collaboration and building three-dimensional models for public safety environments if necessary, if you see that as a priority.